This is ISS rad, the instrument we put on MSL. We're putting a very similar one on the space station, and so this is kind of related in that sense. But you know, she was talking about her teams of 40 people. Now we're going to talk about. Sorry, let me back up one step here. On Monday, this kind of inspired me to put in a couple slides here. Do you guys know whose quote this is? Some would think Mark Twain, right? And it actually is Mark Twain, but I decided that that's really the creed of the 8051 microprocessor, right? Nobody appears to use it anymore, but actually in our group, we still do use it quite a bit. It was certainly not used on all these missions, but this is just a quick overview. You know, I know there's several folks in here from Southwest, and there's many instruments that still use the 8051. We just don't need a lot of horsepower sometimes for some of this stuff. And so it's used on MSL. I mean, we used it on the RAD instrument. There's a couple of them on the ISS RAD instrument. I know Martin has used it on the UVS and several of the Alice instruments. So it is still alive and well and kicking. It mostly lives inside an FPGA core now, as opposed to, at least for us anyway, as opposed to a separate part. I'll skip through some of these slides pretty quick. Again, other end of the spectrum, when she had 40 people, it's fairly common and typical for instruments over here that the person doing the developing, managing the software and everything, the team might well be just one person, two people. If we have a really large team on a particular project, for the flight software that is, you know, we might have 3 or 4 people. So it's the responsibilities that we have kind of, it scales all the way from the management of the software project all the way through to, unfortunately, as several others have talked about, the project never lets us go. We're the ones that actually, you know how to operate the instrument, and so we get stuck into operations, and some of these things take years and years before the project will completely let you go. Like New Horizons, for instance, will probably take me into retirement. The purpose of this talk is basically, you know, using continuous integration. Do many of you folks have the continuous integration concept? Are you applying that with your stuff? I know there's a lot of folks that have, and we're taking our steps into that now. Up until recently, we've been more of the traditional waterfall, where we do a whole lot of development stuff, and then at the end you have these massively complex test procedures, and that's when you find out that, oh crap, there was something I should have fixed maybe 6 months ago and stuff. So we're trying to get away from that, get a little bit more flexible and agile-like. You know, you can't quite do complete agile, but we can at least take some of the steps that we've learned from that. So anyhow, there's increasing pressures here with the, to try to figure out, I got to see here if I, okay. To basically keep track of, you know, the problems that we have essentially are from the management standpoint, and unfortunately I'm kind of caught in that purgatory of where I'm kind of half manager and I would like to do technical, but I end up getting pulled more and more into the management type stuff. So I'm going to drag y'all into this purgatory with me for this presentation, right? But the project managers, or the people higher up, they certainly are getting a little bit more demanding about, you know, the insight into software and the progress that you've made, and where we are with schedules and such. And the problem that we've had on a lot of these things is that we get, you know, these things, even for 8051s, you know, the stuff will get more complex as time goes on. The 8051s are still 24 MIPS, I think, is what we've been able to knock out of those, which isn't bad if you're doing stuff that's not a lot of data processing. But we also run into the damn scientists, you know. I don't know how many of you work with them directly. You know, we do a lot with the detectors, but they play these tricks on you, right? It's like they won't know the answer to some of your questions, and they're saying, well, let's make it configurable. Well, if you've been down that path, that can be very painful for testing and everything else. You know, the more things you can say, let's make it that value and move on, it makes your life a lot easier. They usually don't give, and so the scientists are basically, they need the configurability. They have the attitude generally that, you know, well, we can fix it with software later kind of stuff. And then this happens to us all the time. Maybe you guys have experienced it, maybe not, but after launch, they'll say, oh, by the way, we need to change these algorithms and things like that. It's stuff that happens, but scientists are kind of notorious for doing this, for those of you that have worked with them. And then also, of course, you know, the documentation overload that we get, there's just, you know, we've kind of gotten into a thing where there's certainly a lot of documentation that's necessary. A lot of it is kind of some kind of a heritage type documentation, and sometimes it appears that we spend a lot of time and effort, you know, creating documentation that that really isn't used so much down the road. And so kind of reducing some of that can help also. So from our case, in order to integrate this continuous integration and get some other metrics that are useful for us, for our standpoint, again, like I pointed out, we have small teams, so we need to be really efficient with what we're doing. You know, like I mentioned, the management and the technical development can be and often is the same person that has to fill both those hats for a lot of our projects. And then the folks above us, you know, they're getting a lot more demands for the earned value management. They just have a lot of pressures to keep track of the scheduling there. And one of the problems that we've had is, you know, we might have this nice software schedule within the master schedule, but often you get into the task of, you know, here's the task for coding a build or something, and it might be, you know, in the past we've certainly had, you know, 200, 300, 400 hour tasks that are just a single line item, you know, for build 1, 400 hours. And that's been okay in the past, but now essentially is with earned value, it makes it very difficult if you don't have insight, true provable, you know, some sort of metric to say where are we at in that 400 hours, because the project managers start to go crazy when they're sitting on this 400-hour task that they can't tangibly say how much of it is done or not. I don't know if you guys have had that pressure or not. We certainly have it here quite a bit to give them some baseline for really where we are. And then, of course, the other driving reasons is just with the programmers and stuff, we like a lot of the things that they do with the agile and the extreme programming. And so some of those philosophies, we're trying to find the right way to group that into our processes. And plus, the bottom, I just like to stir the pot and see what happens with changing some of these things and seeing what works. So how do we get things back in cost? Well, I mentioned some of these things. You know, if we can, we'd like to reduce some of the bloated documentation that seems to be just the way that we've been built up and brought up with doing the software in the old-fashioned way. Reduce the processes that provide little value, refine the development processes, and essentially what our goal is, and it's not always clear to figure out how to get there, but it's basically, you know, if we can let the developers develop and you don't have the developers, you know, if we can kind of disassociate them from having to do the mundane management or the bureaucracy or stuff, if we can just let them develop, and then the metrics and the reports and stuff can just fall out of the work that they do as a normal course of work, they seem to be happier, right? If you basically stop them and say, hey, you need to stop what you're doing and go fill out all these reports or do this documentation, a lot of pure developers, yeah, they'll kind of hem and haw a little bit, and it might be kind of painful for them to do some of that sometimes. Just a quick one, what we've done is basically adopt the NASA spiral methodology where you do things in cycles and iterations. Again, it's going down the line that we're trying to do stuff in an agile-like fashion, but let's get to the meat of this. Software management, that just happens to be the tool we use, which is FogBug's, not a plug, that's just what we happen to use. The good thing about FogBug's is you can track the bugs and the features, and you can really do a good job with the different things that you're tracking for software management. But the really good thing for us is that we do a lot of Python also, and it provides a nice Python interface to programmatically, you can get to any of the data, update data, edit stuff in the database there. So that's kind of nice that way. So the continuous integration, for those of you that do it, you know, it's a practice where the team members integrate their work frequently, and you're basically, you know, each integration is verified by an automated build and test that will detect the integration errors as quickly as possible. So what we've set up on ISS-RAD is, you know, the programmers here, we check into a Mercurial repository however often that the developers have updated things. So it'll be daily if they have new code to push in there. And then we have a build test server that will, it's similar to a cron job, although I think we're using a slightly different tool right now. It'll go grab the code nightly, you know, pull it in, build the code, and then it'll talk to the GSE that we have for the ISS, and it'll go ahead and push the code on there, and then run a series of tests that we've created for that. Now the nice thing is the test that we have, the results of that get stored to a database, so we'll have an entry, you know, each night for just how things are progressing along the way. Again, we have the automated process for the building and testing nightly. The test scripts, what we had to do on the GSE is it's the full-blown, I think it's lab Windows in this case that we have, and it's the full-blown, you know, the GUI, the buttons and clicking, you have the full interface there, but we had to write in kind of a TCP backdoor so that we could independently run Python scripts that could talk to the same GSE and therefore talk to the instrument. The test scripts that we have were written in Python. Greg Dunn back there wrote it, I think it might be on the next slide here. We have test stand that calls the Python, and I'll jump to the next slide and talk about the Python scripts a little bit more. We're using test stand right now. I'll kind of mention later that, at least for us, that's probably not, conceptually it seems like it's the right tool, but it's not quite the right fit for how we're doing things, and we can, there's a word on that later. But the scripts can also run standalone without test stand, so we can use this, and it not only lets us do the software testing, at least at a high black box level, but it's the way we also can support the system test, environmental test, performance test, stuff that's at a higher level that the software guys still have to write the scripts for to help out the team. Let's see. So this one is that's just the overview of the GSE, and I kind of talked about that where we had to put in the TCP client in the back. So this is the testing details for the Python script. So there's test stubs that exist for every requirement. What does he have on the next one? Yeah. So we have the top level requirements in doors, and I don't know, for those of you who work indoors, I don't know if you've done any of the DXL scripting. Very, very, very painful. But there are some scripts that you can actually get essentially the requirements exported out of there. And what Greg has done is basically, if we have our requirements indoors, he has some scripts he can run that will essentially take all of your flight software requirements and then create the testable Python framework, and it'll create the stub functions for testing for each one of those requirements. That is a very useful thing, depending on, when you have a few hundred requirements, even if it's just that few, it's still obviously very nice to have that infrastructure just nailed out for you. So there'll be a test stub for every requirement, and then in the database, of course, it has the traceability back to here's the requirement, and here's the latest status of that. Now I better get going here. The results from the nightly tests, of course, we trend that to see what the completeness of the requirements are, as we go along with the project. So the tests, we essentially what you get is, because that part is all autonomous, you get the regression test of everything pretty much for free once you have the infrastructure set up, of course. I'm going to go ahead and skip past this one just because I know I need to catch up just a little bit here. So the script is generated for each section of the SRS. The test functions are auto-generated. Of course, we have to come back in and fill in the details for those tests. Right now, the way it's set up, it's more of a black box testing. We can test anything through what would be the spacecraft interface for us, which is still obviously very useful. Okay, so now I'm going to talk about the part where we tie this into saying, hey, here's what we can do, so we just go about our work, and we have a very good metric to provide back to management. So the earned value that we get from this, essentially by definition of this, and I stole this from Wikipedia, essentially you need the project plan for what work needs to be accomplished, you need some valuation of that planned work, and then you basically have to have some way to say, how can you tie how much work you've done, how can you tangibly put a number on that? Well, so what we've done is basically said, okay, the work to be accomplished, we're going to just define that as being the verification, how far along are the requirements? And the valuation, of course, is the actual versus budgeted dollars in the master schedule that you compare against. And then the predefined earning rules, essentially, how do you quantify that? Well, it's this thing that we've come up with that's a requirement status. So what we've done is the requirements, as they're being tested or being developed through the whole process, and again, parts of this, the first couple steps are more manual. But then when you get into the implemented, tested, and verified, this is where the continuous integration automatically will update the status of these requirements for us. And what we've done is assign a weighting for these things to say, okay, once we have a requirement, and as a team, we've essentially accepted that requirement as a good one and validated it, we give ourselves 10% credit for that particular requirement, and so forth. And so it's weighted through here so that by the time you are completely done and the SQA and everybody else has signed off on this, you can claim 100% of that requirement is done. Well, if you do that across every requirement and you use the weighting, of course, you can come up with a single number that says, here's how done we are with the software, right? And so, ironically, these numbers here were literally, it was hallway talks with Greg Dunn and John Hanley and myself, just trying to say, okay, what seems like the right numbers? How much weight would you give this if you, for instance, if you finish the implementation, or if you've actually done some sort of informal testing as a developer? And these numbers were independent, but then as I did a little research later, they actually aren't so far off if you're looking if you start kind of tying these things where they're talking about designs and the coding and such, they actually seem to fall in line pretty good with some of the, I think this was, I don't remember if this was from Kokomo also or not, but this was from an Agile presentation that I found. So what we have then is we have doors as our top level requirements tool. What we do is go ahead and import that. For simplicity, it's very difficult to programmatically interface with doors. You certainly can go sit down and do manual stuff, but we found it much easier. We have a script that basically will put it into this FogBugs development, our kind of software management tool. We'll get all of our requirements where we can track that in this tool. So doors, basically, we have our top level requirements imported here, and that's where the developers basically work in this environment with finishing it out. The continuous integration aspect, we have the database that sits there in MySQL. Now this part, granted this, we have testing going. Right now there's still we're at the point that we're still kind of doing the manual updates back into this, but we're preparing to kind of do the Python script here that can take the results from that database and automatically update the stuff back in FogBugs so that it'll just kind of show up as a number and we don't have to go in and manually calculate that stuff. So anyway, what it gives you is when you start looking at the metrics tools, of course, it gives you a result of how done you are. And in this case, you can see, okay, here's some level, and you can't quite read it across the bottom, but these are basically like the accepted, the designed, implemented, and so forth across there. And you can see that, that little curve will kind of slowly creep off to the right side as you get closer and closer to finished. Now the good thing is, like, these are some numbers here. These two are a little bit off, but this is essentially effort that we have in costs versus what our requirement status is telling us. Now the interesting thing, we know we still have to tweak these numbers. We don't have enough history yet to be able to say what those numbers should be, but this is a fairly short term over a project, but I have this same data as far as how the requirement status relates to how many dollars that we've spent. I have it across about 5 different software projects that we're running right now, and even though we're going to have to accommodate for some offset, which is probably kind of the kickoff, the dollars that you spend at kickoff and things like that before you really get rolling, the lines seem to trend pretty well. I mean, they follow each other, even though there's the offset of which we'll have to figure out how to accommodate for that at some point. But I am actually optimistic because all of the projects seem to have that same trend of where we're doing something that's obviously pretty close to right. And it gives us a number, by the way. So now when you're in the middle of that 400-hour task or whatever, and the project manager's beating on your head saying, show me how much done you are, I can actually go give him a number that I have some sort of evidence to back up. So the advantage of this, now we are trying to get, part of the other thing that I didn't mention is, we have a lot of these projects that we've done where there is a single person that's pretty much that entire interface. We are trying to get, we have a very small team and a small group, but we're trying to get better about separating, the management from the testers, from the developers, so that we can get a definite separation there. And pulling out that continuous integration, it kind of forces us to do that because now we have to develop this test code at the same time the developers are developing the flight code. And so you can't have, it's more difficult to have one person do both because they really both are happening at the same time. And of course, once you have the infrastructure set up, the regression testing is free. You can run it over and over again, of course. As many people have noticed, you just know much earlier if you're having bugs or if there's some sort of problem that only shows up occasionally. And then a good portion of the monthly reporting, it starts to get closer to automating at least a good portion of what they want in the monthly reports, which can be tedious if you have to go data mine everything every month. The issues and concerns, I mentioned test stand earlier. I think test stand is a fine product. It seems like it's just not quite in cahoots with the Python scripting and getting things set up like we want. So I think in the future we would probably, we might stray away from test stand and actually just have a Python structure that can do the storing in the database and calling of the tests. And then currently we're pretty much limited to the black box testing for this because we do it through the GSC, which is inherently much like the spacecraft, right? And we don't have the insight as to some of the requirements that we might need to test that are lower level or something that we need to test on the board. So the current status here, we have the Python framework is fully functional. I think the automated build, Greg has got some tools working for that now. The GSE and everything is working. The initial FTP scripts We have used this framework now for some early testing that we did at Johnson. The actual full suite of tests that we need for the software ATP, we're still developing some of those. We still have a ways to go with that, but the infrastructure is all there, so now it's a matter of filling in the blanks. And the last one here, actually, this was outdated now. I think Greg has this up and working these days. So where to go? When I first started going down this path, what would be nice, of course, is if you have the logic analyzers, where you could fully instrument a software test unit, and if you programmatically can get at the logic analyzers or the scopes or things like that, then as you start to grow, you can talk to those and do much more white box testing, and that would be really nice to do that type of stuff also as necessary. To automate as much as the monthly reporting as we can so that we can just develop and it just as a byproduct of what we're doing would be wonderful. We certainly need to gather more data. We'll have to figure out what the right status weighting is for those. And we also talked about adding infrastructure so that as the autonomous testing is happening, if it's indeed a new bug that we see, that it goes ahead and just automatically will add a new bug into our bug tracking tool so that we don't have to always go dig through it and manually go make a case for that. And then I want to thank Greg Dunn. He had helped me tremendously with getting this prepared, and he had a lot of insight when we were stuck on what the hell we're going to talk about. He helped us kind of get that fleshed out. So that is it. I bored you to death, so we'll see if anybody's awake enough to ask a question. Yeah?
So you talked about Cron and MySQL. Did you consider using an already built framework like, say, Jenkins to do a lot of code management?
So the perfect person to ask is 2 doors down from you. Yeah, so the answer to that one was if we used a framework instead of cron, and indeed we didn't use cron. Unfortunately, we're using a Windows system right now, even though most of us are kind of Linux guys. Some of the tools that we have available are driven from Windows. And I think Greg has used a tool called Hudson, which is a really cool little tool. I mean, it has its own little web server, and you can see the differences in builds and how things have progressed along with that also. Is that a fair summation, Greg, of that part? Yeah. Any other questions? Yeah, it's something that we kick off every night, and then you come in and you grab your coffee and you go, oh crap, there's the results.
Okay. Just from experience in other projects, using 4 to 6 hour tests, most tests you could use the interface, which is usually a 1 command per second one.
Yeah, right. Yes?
How much time have you spent putting this together, this framework? It's something you put together, you spent some time doing it. How was it? A lot?
Well, there's been different pieces, and it's kind of come together a little bit at a time, as opposed to being like, here's a vision, and we just need to go for that, right? And I know Greg has spent a bit of time. I'm pretty sure you modeled the Python test infrastructure stuff. I don't know if it was off a check or which one that you modeled off of, but it was modeled off of one of the I guess the open source unit testing type framework, I believe. It has the test runner and such. Which one did you model it off of, Greg?
That is actually, I wrote that, but it's, I wrote code. So as far as for RAD, it was stored in place. The exporting from doors for all the stubs was pretty slow. So like you said, it was really a matter of getting into a form. It was written with Rubber to use the rest.
Yeah.
So the porting it towards the CSV was slow.
Yeah, and I think a lot of it, Robert, is it's little pieces that on different projects as we put together, some of the different stuff I've done, Greg's done, he did a lot of the stuff on Hope, and it's starting to tie those together into something that's just slightly more, well, it makes it more useful when you can tie them together and type stuff. So I don't know that, it's kind of hard to say what's a single effort that we put into it, because it's just, things have been slowly modified and coming together like that.
You built the pieces over time, and now you're...
Yeah, and now it's kind of obvious, or we think it's getting kind of obvious on how we can tie them together to actually make them be more useful for us.